Hey all. Earlier today, Primogen and Low Level Learning released a collaborative stream about the Zig programming language. And during the stream, chat said that Zig doesn't have error payloads. I'm going to link to the stream below, queued up to that time. Well, I've done a lot of Zig programming, and I happen to think that that's not true. And so I decided to make a video showing how I like to do error payloads in Zig. The thing is, it's not entirely obvious that this is the right way to do things, and you know, if you have a better way of doing error payloads in Zig, feel free to share in the comments how you do it. But I think that the way that I do it is strictly better than how error payloads get done in pretty much any other language. And I'll explain to you why in this video. So let's start by taking a look at the code. So this is the code that I'm going to be running. It's a pretty simple program. Let's take a quick look. There's a main function. And when we call this main function, it's going to assign this num variable to the value 42. 42 will be passed to this add error function. We'll go over what this anonymous tuple is, or struct is doing later. If this add error function errors, then we go into this panic. And if it doesn't, then we're going to just go ahead and print the number. How does the add error function work? It looks at num and sees if it's 42. It returns this error field here. Otherwise, it just increments the number and returns it. So let's run this with 42, and hopefully you can guess what's going to happen. Sure enough, what happens is we get a panic with the error bad number because add error noticed that it was 42 and returned an error. This is basically how errors as values in general works with Zig, and it's a very, very powerful feature. If instead I change this number to something else, we get what we expect. The number is incremented by 1, and we then fall through to the point where we print the number. Okay, but this doesn't have an error payload. And the problem is that these errors are 16-bit integers at most. So they can't carry any meaningful metadata with them besides just besides the identity of the error that got returned. So how are we going to do it? So I'm going to start by copy pasting some code. And the first thing we're going to do is we're going to change this unused variable to a variable opts. And what I'm going to do is I'm going to add an extra line right before we return this error.badNum. And here's what it does. So it checks to see if the opts variable has an error payload field. If it does have the error payload field, then it will go ahead and set that error payload to the string gotBadNumber42. And then it returns error.badNum. Okay, so what happens if we run this? Well, let's take a look. It does exactly the same thing when the number is 47. And if we change this to 42 and rerun it, now we're going to have a problem. It just goes ahead and does the panic error bad number. Exactly as it did before, basically nothing unchanged. And that's because we didn't supply an error payload field to this option. So let's change that and now add an error payload. In this case, we decided the error payload was just going to be this string. So let's go ahead and make a place for that error payload to go. So that's how we do that. Of course, now error payload isn't being used. So let's go ahead and do this. Oops. So we're creating an error payload field and setting it to the pointer to this U8 slice called payload. Now, in this case, what we're going to do is we're just going to do something with that payload value, which is to print it out. So now this payload metadata should get transferred into this payload variable, and then we can go ahead and use it, in this case, just by printing it. So let's run this. And here you can see, right before the panic, we got error got bad number 42, which is exactly the payload metadata message that we had before. Of course, if we set this to 47, then nothing happens, and instead we're just going to get the number 48. Okay, so in practice, this doesn't have to be a string. It can be something more complicated like a struct. And the other interesting thing about this is because we're using this opts field, which is effectively an anonymous struct, if we have other options besides just an error payload, we could conceivably stash them into the same variable and pick them off using a similar strategy as this, where we check to see if it has a field and then do something in response to whether or not that field occurs. So now that you've seen this and how you actually put this to practice in code, I think that it's also important for me to explain why I think this is a superior method of doing this. So the way we're going to do this is we're going to take a look at Compiler Explorer. So this is a website where you can actually compile some code and take a look and see what code it produces. So in this case, what I've done is I've generated a couple of functions, in this case add and add error, which are pretty much basically like what we had before, and I've commented out a couple of lines here. Now what we're going to do is we're going to step through the machine code and understand what exactly is going on in our code. So in the function add, which is indicated here with add a colon with the symbol add, first thing we're going to do is we're going to compare a register with 42. That's actually, as you can see here, that red num equals 42 section. And if there's an error, it will jump to LBB B_2, which is basically this zig panic. Otherwise, we're going to add 1 to the register and then return that value after moving it to the EAX register, which is where you expect the result of a function call to happen. Note that none of this code, the if has field equals type of error payload, none of that at all appeared anywhere in our machine code. Next, what I'm going to do is I'm going to go ahead and uncomment these two lines of code, which are effectively the case when we do choose to use an error payload. And next, what I have to do is I have to actually set the error payload equals the pointer to payload. And now we can see that after that compiles, yes, there is a bunch of extra stuff here, which is all to do with the print, but we're going to ignore that. But you can see that here it has gone ahead and added a bunch of extra lines of code that correspond to assigning this got a bad number message into this into the payload variable. So what this means is, and of course this could wind up being much more complicated code depending on if your error payload is more involved. It could be a struct. Maybe you have to do some computation to actually return a meaningful error response. But the point being that in the case of Zig, at compile time, it's known whether or not you are providing error payload into the options. And so what it will do is for the add error function, it will optimize away any lines that have this has field error payload if you don't pass an options that has an error payload field. Moreover, you can even in the same program have multiple calls to a function that takes an option, some of which will put in the error payload and some of which won't put in the error payload. And depending on whether or not you've put in the error payload or not, it may call a different version of the function that supports the extra code necessary to do the error payload delivery, or doesn't do it at all. And so that level of optimization and omitting code that you don't ever need just because you didn't pass it as a request. So you can think of adding this error payload and say as a mechanism, especially when you have this has field type of operation, as a way to say at the call site, say, hey, please, I care about more information about the error, so please give it to me. And if you don't, please optimize away any code that you would need to give me back a payload. So that is my favorite way of doing error payloads in Zig. You should, of course, tell me what you think, if you think this is too complicated. And of course, there is a burden on whoever is writing these functions that have this optional error payload to document the fact that the error payload field is optional and possibly could incur extra work if you do include it. I hope you enjoyed that. A future video that I'm going to make will cover my library Ziggler. I have an 0.12.0 release, which corresponds to Zig 0.12.0. And in this library, I extensively use this technique to build beautiful error payloads. So if you are interested in that, stay tuned to this channel to see that video. All right, thank you for your time.